Hello, this is Ariel from the EFVT team for Fall 2019. So today I'm going to be reviewing the web API functions that we worked on, and I just want to kind of go over what the process is. So as you guys know, this web app uses the entity framework, so it has different layers. So whenever we receive a request from the sync expert, which the EFWE team, Juliana, worked on, she probably explains that a little bit in her video. So basically, when a request is made to get account equity, it comes to the account equity controller, which is located in the web API folder. If you come to web API, you open it, and you'll see all the different controllers here. The first one is account equity. So here we made a function and we called it get account equity. And basically it uses this request. You can test it on Postman, and with this request you can send values to this function and it'll process them. So in this function we get a login ID, a start date, an end date, and a time frame. For those who don't know, these are the same exact variables of the get account equity function that is used in the account equity repository, which we will get to eventually. So in this function we create a new start date and end date, we parse it, we create a forks login, we get the fork using the forks service, we get the login ID, and then we create an instance of account equity, and we call the account equity service instance, which was created within this controller, and it calls the account equity service, which is an instance of account equity service. Account equity service is an interface that's also located in the web API folder under interfaces. So if we come to the web API function folder, we're gonna have web API here, controllers, we're gonna close it. We go to services, and inside services there's another folder called interfaces, and here we'll find our account equity service. So when we go here, we basically initialize the function that gets called in the controller, but without a body, very similar to an interface in other object-oriented languages. So within the web API controller for account equity, we have a log account equity and a get account equity. The function we worked on is the log account equity. So we come here to account equity service. Apologize, let me show you the log account equity. This is the function me and Guillermo implemented. So what first thing it does is it uses this request. This was initialized before we received the project. This is the one we created. So we created a request that whenever it calls log account equity, no parameters necessary, it's going to check if the request is a bad request. If it is, it's going to return forks account is not found. Since this log forks request is implemented elsewhere, it has specific values that come in the function, and it processes those values. And then we have a time string. Since the forks request returns a date as a string, we convert it into a date time variable, because that's the only way that the get account equity function will process the information later on. So we create an instance of account equity, and we call it forks equity, and we assign the values based on the request. Now you're asking, why are these four the same? Well, whenever a request is made for a specific time slot, whenever a new record is made for a specific time slot, the first record is always going to have the same opening value, closing value, high value, and low value. Why? Because it is the only value in that time slot. So it's basically a default, and that's what we've created here. We've assigned login ID to a corresponding login ID from the request, and then the request has two more values. It has a equity value, which we assign to open, high, low, and close, and then it has a time slot value. Those three are the ones that come, values are the ones that come within this request up here. So we request the value and we assign it to open, low, and close. Also, if you guys don't know, this is an entity, and we create an instance of that entity, and the entity has these states here. So we have to assign a value to all the states within that entity, and that's exactly what we're doing in this instance here. Since this is the very first instance in this time slot, we're going to assign a default volume of 1. And what volume would do is, if another value is triggered, if the sync expert picks up another value within the same exact time frame, it's going to increment volume, and then every time frame itself is going to have a specific volume every time slot. So let's say at 12:01 it'll have a volume of 10 because the function ticked 10 times in that minute, or in 12:02 there's going to be a volume of 20 because sync expert ticked 20 times within that minute. So that's what this function does, only is assign a default value of 1 if it was, and then with this information later on we're going to process it to see if this specific time slot already exists and how to update the volume. But once again, just to reiterate, this is a default, assigning default values. So then we have an additional step to make sure that the equity was created successfully. We created a boolean, and then if the boolean is false, it'll return bad request, and if it is okay, then it was successfully logged. So like I mentioned earlier, this function calls, this function is created in the iAccountEquity class, and then this is called the regular account equity service, which is located outside of the interfaces folder inside the same services folder. So you'll see account equity service, and here you'll see the log account equity, and we have another check to see if the instance that we created is null, and if it is, then return false. If it is null, then return false, and if it is not, return true. But before we return true, we call the account equity repository, and we call the log account equity function, and inside the function we have our entity that we initialized prior with those default values that I was talking about. And here, this entity holds all those values that we were assigning to before. And this account equity repository was created at the very beginning as a read-only variable of the iAccountEquity repository. This is an interface of the account equity repository, which will be located not in the web API function, but rather in the data access folder. And once you're in the data access folder, you'll go to repositories, and inside the repositories you'll find the interfaces folder. Inside the interfaces folder you'll see iAccountEquity repository. Very similar to the iAccountEquity service, this just initializes the functions within the account equity repository class. Then once we go to the account equity repository class, this is where most of the calculations are done. As you can see, this function was here when we received this project, and it's the get account equity function. This function basically gets all the data from the database and populates it to the staging server or the production server as visual data. An important thing to note about this function that we added is this as-no tracking function. Since we are using a read-only variable, it is important that we do not keep a track of our queries, because since read-only variables are not processing data into the database, there is no need to track the queries. And the issue we were having is when we were tracking the queries, it was not updating the primary key, so it was duplicating the very first data row multiple times. So by adding this, we're telling the function, hey, we're only looking at read-only variables, so please don't keep track of the queries that were being called. And with this, we were able to populate data to the graph. However, what we worked on mostly was this log account equity function, which gets the equity from Forex account, processes it with a login ID, Forex ID, and puts it into the database. So this function adds data to the database, and this retrieves data from the database and visualizing it. So once again, we have another check here. Forex is null, and return false is probably not necessary, but we were just following a standard and we kept it in there. So the first thing we do in this function is we create a var result, and inside here we have the repo context, which is an instance of effort context, which is inside our context folder. And the important thing about this is that it has all our entities within it, so by calling this, we're able to use any entity. So if we go back here, we see we have repo context, we call our account equity DB context. My mistake, these are not entities, I believe they're DB context, which are used for initializing get and set functions. So we use a first or default function, which is used to gather data and add it to the variable t, and then t is going to be the row that we're looking at specifically. So we're gonna basically says, okay, hold this value in t. T's time slot minute has to be equal to Forex equities time slot minute. If that is this, what's basically what's this saying is, if a row exists, if a time slot of 1201 in the table exists, for example, then store true as a result, or store the row, the existing, not true, I'm sorry, this is not a boolean, store the existing row in the variable t. And by doing that, we can manipulate the instance of that row, and we can update values like open, close, high, low, and volume. So what we did is we matched the minute with the minute to make sure they're the same time slot, and that the login IDs are the same, because there can also be multiple login IDs with different time slot with the same time slots, which we wouldn't want to update another login ID's time slot if it's not matching the Forex ID that we requested earlier in the account equity controller. So once we have a result, if it's not null, meaning the record exists, then we compare the high value that we're receiving from the function with the high value that is currently in the database. If the one that we're receiving is higher, then replace it with the one one existing in the database. Basically, if the equity raises in value, we want to make note of that, because that's the highest value it would have this minute. So we would need to have, that's what the highest state is for. Then we also have the same logic for low, and then close is always getting updated, because you never know when that tick, if the tick that's being sent to this function is the last value. So you always want to update close, because if the minute changes after the next tick, then you already recorded the last value that the time slot had, the last equity value that existed in that time slot. And as also, we always update volume if a record exists only. And since we're using effort context and we're adding data to the database, and we're not using raw SQL, we have to use a save changes function to push the changes to the database. Therefore, if it doesn't exist, else we just add the entire entity that we're calling with the function to the database. Now, why do I not initialize any values? Because we already did that. inside the account equity controller, which is what I was talking about here. So basically any values that we add to these columns here, we're just going to add them directly to the database with this add function. We're going to add that whole entity as a brand new row, and then we save changes in it again, and then we just return true. So that's our log equity function, and we were able to implement it successfully, but we currently don't have any visual data to show you. But basically it populates as expected. You see the volume here is 502 at 15.1. Let me see if I can get minutes better. Well, basically, it's supposed to say for the minute here, it has 502 ticks. That means that our function was called 502 times, and it was updated 502 times within that minute. Anyways, going back to the code. So, obviously, we still have a few bugs within this function, which was one of our shortcomings. But another shortcoming that we had is the professor wanted us to implement a balance graph right under this, under the equity graph. Balance is very similar to equity, except the balance is just showing the difference in value over time, and it's not focused on the highs and lows, more open and close values. Since it's almost the same logic, we've already gone ahead and implemented it, and it's under FIU balance repository. You can see here is the same exact logic, except and instead of the account equity controller, it uses the FIU controller. Let me see, FIU balance, FIU. FIU controller.cs, and we're going to have a log balance function. We're going to look for log FIU balance. Same thing as the other function. The logic, basically the logic is there. We just didn't have the time to implement the visual graph. So that would be one of our shortcomings. Another shortcoming that we have is that every time we make an edit to the graph, it defaults to the hour time slot, and we don't want that, because if we're zooming in, and we make a change, well, let's say I want to take off the moving average, you see how it defaults back to the hour. We don't want that, because we want to work with the same data we're looking at. So that's something that can definitely be improved on the website. And besides that, the code can be cleaned up a little bit and probably improved in performance. But besides that, once that graph is implemented, then it's just going to be improving the features of the website. However, if you have any further questions, you can always reach out to me. Let me see if I can provide you my email. If you have any further questions, I can try to clarify as much as possible. But this is my email. If you have questions or anything about the work we did, and if something doesn't work the way you expected, or if something happens along the way, please feel free to reach out, and I'll try to clarify as many questions as possible. Thank you.